And it looks like we're live. Audio is working. We can do a test there too. Audio working. Perfect, it is. Let's go ahead and share this out. Okay, and messages sent. Good Monday morning. Although that's not my catch line, so I can't use that too much. It is 7 a.m. Mountain Time here, so it's time to continue on learning Rust. So last we left off, we were just about to begin write a failing test section. I think we actually read off this paragraph, but it has been an entire weekend since the last time we did everything. So I figured let's just start over again. And I think I got everything configured the way I want it to. Looks like there might be some weird flashes or something going on like right down in this area. Just sort of looking at what the preview is showing, but if it ends up bothering you too much, let me know and I'll see if I can fix it. Other than that, I'm going to go ahead and keep on moving. Okay, so because we don't need them anymore, let's remove the print line statements from source librs and source mainrs that we use to check the program's behavior. Then, in source librs, we'll add a test module with a test function, as we did in chapter 11. The test function specifies the behavior we want with the search. We want the search function to have. It will take a query and the text to search for the query in, and it will return only the lines from the text that contain the query. Listing 1215 shows this test, which won't compile yet. So if you remember, we did begin with test-driven development and we began in the libraries. So we don't actually need to do this. This test searches for the string duct. The text we're searching is 3 lines, only one of which contains duct. We assert that the value returned from the search function contains only the line we expect. So that's the same thing that we were that we did in our first test. We aren't able to run this test and watch it fail because the test doesn't even compile. The search function doesn't exist yet. So now we'll add just enough code to get to the test to compile and run by adding a definition of the search function that always returns an empty vector. As shown in listing 1216, then a test should compile and fail because an empty vector doesn't match a vector containing the line safe, fast, and productive. So yeah, we also followed this sort of methodology of the Red Green Refactor, which simply says write the test, get it to fail, that's the red, then write the code until it passes, that's the green, and then refactor the code knowing that if we screw it up, we have the test to tell us that we screwed it up. Notice that we need an explicit lifetime A defined in a signature of search and used with the contents argument and the return value. Recall in chapter 10 that the lifetime parameters specify which argument lifetime is connected to the lifetime of the return value. In this case, we indicate that the returned vector should contain string slices that reference slices of the argument contents, rather than the argument query. In other words, we tell Rust that the data returned by the search function will live as long as the data passed into the search function in the contents argument. This is important. The data referenced by a slice needs to be valid for the reference to be valid. If the compiler assumes we're making string slices of query rather than contents, it will do its safety checking incorrectly. If we forget the lifetime annotations and try to compile this function, we'll get this error. So it's the error of like, hey, you need lifetimes here. Rust can't possibly know which of the two arguments we need, so we need to tell it. Because contents is the argument that contains all of our text, and we want to return the parts of that text that match, we know contents is the argument that should be connected to the return value using the lifetime syntax. Other programming languages don't require you to connect arguments to return values in a signature. So although this might seem strange, it will get easier over time. You might want to compare this example with the validating references with lifetime section in Chapter 10. Now let's run the test. So they get a failed test because they returned an empty vector. Great, the test fails, exactly as we expected. Let's get the test to pass. Writing code to pass the test. Currently, our test is failing because we always return an empty vector. To fix that and implement search, our program needs to follow these steps. Iterate through each line of the contents. Check whether the line contains our query string. If it does, add it to the list of values we're returning. If it doesn't, do nothing. Return the list of results that match. Let's work through each step, starting with iterating through lines. Iterating through lines with the lines method. Rust has a helpful method to handle line-by-line iteration of strings, conveniently named lines, that works as shown in listing 1217. Note that this won't compile yet, of course. For line in content.lines, I'm actually curious, which method did I end up using? So in search, no, so I didn't. What I ended up doing was I had content as a string and I split it on new line and then collected that into a vector and then I went through and iterated through it. So this would have been faster, and I could do that right now. I could just say, okay, well, instead of, we don't need this anymore, it would be, we have a result for line in, and this will be content.lines. And we should come back, and the theory is this should just work if we do cargo test. And it does. So that refactor worked for us. So part of the problem about learning any language is there are some features that you just don't know exist. This would have been a nice one to have, and we just saved a full line by doing that. The lines method returns an iterator. We'll talk about iterators in depth in Chapter 13, but recall that you saw this way of using an iterator in listing 3.5, where we used a for loop with an iterator to run some code on each item in a collection. Searching each line for the query. Next, we'll check whether the current line contains our query string. Fortunately, strings have a helpful method named contains, which is what we used, that does this for us. Add a call to the contains method in the search function as shown in listing 1218. Note this still won't compile yet. So then they do that here. Storing matching lines. We also need a way to store the lines that contain our query string. For that, we can make a mutable vector before the for loop and call the push method to store a line in the vector. After the for loop, we return the vector as shown in listing 1219. So then they're pushing in to, looks like they're using a new vector. I believe we did too. Now the search function should only return the lines that contain query, and our test should pass. Let's run the test. So they run a test and it works. Our test passed and we know it works. At this point, we could consider opportunities for refactoring the implementation of the search function while keeping the test passing to maintain the same functionality. The code in a search function isn't too bad, but it doesn't take advantage of some useful features of iterators. We'll return to this example in Chapter 13, where we'll explore iterators in detail and look at how to improve it. All right, using the search function in the run function. Now that the search function is working and tested, we need to call search from our run function. We need to pass the config.query value and the contents that run leads from the file to the search function. Then run will print each line returned from the search. All right, so they're creating the run function, which is really just taking in that config and doing all the content, what we're trying to do here. We're still using a for loop to return each line from the search and print it. Now the entire program should work. Let's try it out. First with a word that should return exactly one line from the Emily Dickinson poem, Frog. I'm getting a static or feedback from something. Give me 1 second. There's like the water heater outline just started making noise. I'll be right back. Okay, I think that should solve it. Let me know if there's still some feedback on there. But I ended up just closing the window, which a lot of the noise was coming out of there. And where were we? We're still using a for loop to return each line from search and print it. Now the entire program should work. Okay, it works. And finally, let's make sure we don't get any lines when we search for a word that isn't anywhere in a poem, such as monomorphization. Sounds good so far. Perfect, yes. Excellent, we built our own mini version of a classic tool and learned a lot about how to structure applications. We've also learned a bit about file input and output, lifetimes testing, and command line parsing. To round out this project, we'll briefly demonstrate how to work with environment variables and how to print a standard error, both of which are useful when you're writing command line programs. One thing that they didn't do that we did here was that we also did TDD for the run function. But because it's the run function and it is doing the entire thing, we did that as an integration test. All right, so where were we? 12.4, so now we're going to 12.5. Working with environment variables. We'll improve minigrep by adding an extra feature, an option for case-insensitive searching that the user can turn on via an environment variable. We could make this feature a command line option and require that users enter it each time they want to apply. But instead, we'll use an environment variable. Doing so allows our users to set the environment variable once and have all their searches be case insensitive in that terminal session. Oh, so they're going to use a environment variable for case sensitivity. Writing a failing test for the case-insensitive search function. We want to add a new search case-insensitive function that we'll call when the environment variable is on. We'll continue to follow the TDD process, so the first step is, again, to write a failing test. We'll add a new test for the new search case-insensitive function and rename our old test from oneResult to case-sensitive to clarify the differences between the two tests as shown in listing 1220. So let's go ahead and implement that ourselves here. So we have our tests. We have parse standard in, config So the config errors, it should search. So we're going to call this search case sensitive, and we're going to copy this and create a brand new one, search case insensitive. So let query equal string from duct. So if I just do something like duct like this, out of here, Rust, safe, fast, productive, pick 3, we should not get anything at all. In fact, is there anything in here? Actually, I guess what I want is to add a productive here as well. Because that way I can now say, okay, we're going to get duct with a capital D. We should get this line instead of this line. So 3 productive. Don't forget that dot. Okay, so if we run this test, it will fail because it can't find search case insensitive. That's not really a problem. We're gonna. Okay, so cargo test, we should get a failing test. Yep, search case insensitive, and it failed because we didn't do this correctly because grep search. So we also need to change this. So we want to search. Well, do I want search to be in charge of this? I think I do. But I think the other thing that I want to do is make it so that we're passing in. Well, let's see how they want us to do it. So let's take a look at their search here. So function case sensitive. Here's the previous ones that they have. Case insensitive. There's still search case insensitive and search. So their standard search is okay. I get it. So they're leaving this alone on its own, and they're expecting us to change this to search case sensitive. Now, if we do this, it of course won't find it because, well, it's not going to find that function, which is what our editor is saying right now. And if we do our test, it will also say not found in grep. So now let's go ahead and write this function. So search case insensitive, and it's going to be back into here. So we have search right here. This is probably going to be a copy and paste. Search case insensitive. We're going to have the exact same lifetimes and everything else, except this time we want to make sure that contains, and we need to make sure that this is a case sensitive search. So contains might not be the correct thing to use here. Let's take a look at Rust. What is it? Wester methods. So we did contains last time. But contains is not case sensitive. And actually, let's double check that. I noticed that in their test here, they added in duct tape right here to basically check their original search function too. Let's go ahead and add that in as well. So here's, it should search and find multiple. And this one right here, we can now add, okay, hello, hi there, then what are we searching for? Hi? We can make this a capital H. And this should now be a capital H. If we save this, we should only still have one failing test. It should search and find multiple. Oh, so it does not. So it looks like contains, make all the things lowercase. I think you're right. So 2 lowercase is going to be what we're going to have to do for it inside of search. But what's really interesting is that I thought maybe we'd have to do something for the case insensitive, but we're going to have to do to the case, wait. Opposite. I thought we were going to have to do something to the case sensitive, but we're going to have to do something to case insensitive because contains cares about case. So, and what are you caring about right here? Search case insensitive. Actually want this to be, this is case sensitive. And you're insensitive because you don't care at all. You should just work. Whereas you, so case insensitive will come through and say, okay, I've already confused, like I've just let sort of like which one is which. Okay, so search case insensitive. It's the one that doesn't care, right? It's search case insensitive. Poor function is such an insensitive jerk. Oh, I like that. Okay, so case insensitive means it doesn't care about the case. So if we're searching for duct, then we want, this can have a capital D and it should work, which means that this is a capital D. Insensitive means that it does care about this, and it will only find pick 3 productive. Also, I don't know why I thought that capitalizing, I need to capitalize the D to make that work. And also, insensitive doesn't care, right? I named these both the same thing. I named the top test wrong again. Okay, so insensitive doesn't care. Sensitive does care. So this one should work. Pick 3. Okay, so with this one, I'm gonna just name this. I'm gonna just say we have to name this differently now. So search case insensitive. Search case sensitive. Okay, so we're gonna do that. Insensitive is the original one. Search case insensitive, so let's come up here. You become that, and you become search case sensitive. Okay. Then let's run the test and see where we're going wrong with each of them. Assert equal. Oh, so all my other tests. So these are all from the original test, which were search case insensitive, I believe. Also, you just added in all that stuff I did not want you to. Okay, so let's try this. We should still get a failing test, but at least I want it to run normally. Okay, so let's take a look at what we got here. We got 3 failing tests. Search case sensitive failed, search and find multiple, and then search case insensitive. So search case sensitive, let's take a look at this. Left, pick 3, productive. Right, pick 3, productive. Why didn't you work? The capital D. Did I? Okay, case sensitive. It's because I was expecting it to find. So in case sensitive, I'm searching for this one. It should only find the one with the capital D. And that's because if I'm searching for this and I'm case sensitive, then I'm only going to get this one. So I gave it the wrong success term. So let's try it again. Two now. Okay, perfect. Now, it should search and find multiple. It should search and find multiple, panicked at assertion. Left is hi there, right is hi there, and hi there. So this is, it should search and find multiple, which is right here. So the result is supposed to be both of these. Assert grep search case insensitive, meaning that it doesn't care at all. We passed in high, so we should be getting both of these. And we ended up getting just hi there instead of both. Hi there, hi there. So we did set the result and the string as correct here. Okay, so query content, and then we have the result. So we need to fix it should search find multiple, and as Stacking you said, we can just make everything lowercase. So we want to see, is there a way off of strings to make everything lowercase? Look like there's hair in my eye or something. Okay, so make ASCII uppercase, make ASCII lowercase. Convert this string to its ASCII lowercase equivalent in place. ASCII letters A to Z. Okay, so make ASCII lowercase, but I don't. To return a new lowercase value without modifying the existing one, use to ASCII lowercase. Returns a copy of this string where each character is mapped to its ASCII lowercase equivalent. Okay, so that's what I want to do. To ASCII lowercase, and it returns a full string. That's interesting. To ASCII lowercase. So this is search case insensitive, where it's not supposed to care. Here's our result, 4-line and content.lines. I kind of want to just shadow this and just say, or maybe I should just say lowercase equals lowercase content equals content dot to ASCII lowercase, and we'll end right there. And then in content, this becomes lowercase content. All right, so let's try this. We've got an error here. Lowercase content does not live long enough. Borrowed val. Oh, right, because now I'm returning based upon this. That's interesting. I wonder if it'd be better. Content is a full stir, and I'm getting the lines from it. I wonder if I can. Oh, interesting. Okay. Now I could hand the full string in. So instead of a vector of a string stir like this, I wonder if I could do a full string coming out, which is no longer just handing a reference that then gets deleted right away. It then goes away. So for line in lowercase content, result.push. Let's try this. Okay, so it expected standard string found stir. Where did it find that? Function search case insensitive vector stir. Wait, did it? I thought that I made it so I'm pushing in here. This is just insensitive, right? Yeah. Insensitive, I'm pushing the line. The line should be lowercase content to ASCII lowercase. I guess my other choice is result is a stir. Oh, result is a stir right here. You're right. Make that a string. Now line expected struct standard string found reference to stir. Because lines. Oh, so I'm gonna have to. So the problem that I see is that if I do the to lowercase inside of here, if I end up doing the to lowercase inside of here, I'm going to end up with just a huge spaghetti of borrow and ownership problems. This changing everything from string to stir is killing you now. I know. But I wonder, this might be really weird, but could I do this twice? So I've got content, which is just a stir. So it's just borrow. It's a okay. So it's just a borrow. It's just something like that. I wonder if I could then end up having both. If I could have both of these, then I can iterate through, check one of them, and then put the other one in, so we don't care about it. The other choice is that we could put the two lowercase before we pass it in here, but then we lose the capitalization, so we don't keep those either. We could enumerate here, I think, and then we'll get the I. So for the index and line, which doesn't really help. It just lets us know which ones to end up putting in here. I'm actually curious about what they're gonna do. So let's read on and figure that out. But I think I don't want to go back to strings. I want to stay as strs if possible. So I'm curious about this and sort of like seeing what they're gonna do. Okay, so the new test for case-insensitive search uses Rust as its query. In the search case-insensitive function we're about to add, the query Rust should match the line containing Rust with a capital R and match the line trust me, even though both have different casing than the query. This is our failing test, and it will fail to compile because we haven't yet defined the search case-insensitive function. Feel free to add a skeleton implementation that always returns an empty vector, similar to the way we did for the search function listed 1216. So implementing the search case-insensitive function. The search case-insensitive function shown in listing 1221 will be almost the same as the search function. The only difference is that we'll lowercase the query and add line and each line, so whatever the case of the input arguments, they'll be the same case when we check whether the line contains the query. So what we see that they're doing here, 2 lowercase off of the query. So str did have a lowercase variant. Well, so I was able to do lowercase off of this str right here. The problem is that according to the documentation, it returns a string, a capital S string on the heap, as opposed to a reference. And oh, 2 ASCII. I wonder if I could just do 2 lowercase. Well, according to this, it still returns a full string. Which isn't really helpful. Let's returns the lowercase variant of the string slice as a new string. Lowercase is defined according to the code, blah, blah, blah. Since some characters can expand, this function returns a string instead of modifying the parameter in place. And since I'm not passing like a mutable version around, I can't do the lowercase it in place. Okay, so let's come back and see what they're doing with it. So they have query 2 lowercase. They have their standard vector of results for line and content.lines. If line 2 lowercase contains query. Oh, so they're not carrying. So one thing that I notice here is they're not caring about it retaining its case when they're putting it back into when they're returning it. Because query here is gone. If line 2 lowercase contains query, so we lowercase both sides. Also, this is interesting. Why do they do both? If query content, where's content come from? Contents.lines. Oh, I see. Okay. I see what they're doing. Results.push line. The problem is, and I'm curious about how they're going to solve it, is that this returns okay, because they're doing the iterator off of contents, they don't have to worry about the reference or the lifetime of it. So really, we're just doing, okay, lowercase content, content to lowercase. And then we have the query. I think it's the query that we care about right now. So we want the query to be to lowercase equals query to lowercase. So we shadow that. And then we have, okay, so we have our new result here. For line in lowercase content, I don't want to do that. I want to go over standard content.lines if line dot to lowercase. So if this contains the query, which has also been lowercased here, then result.push the line, which we don't care about. Then we don't have to change anything at all. So we're back to the B stir, and this is going to be a reference to a string, and then we should be fine. Okay, so the trait standard operations fn mute char is not implemented for standard string. So contains, if line.to lowercase contains, oh, so this is not on strings, this is only on stirs. So if line.to lowercase dot contains, that's right here. So we can't do contains off of a string, we can only do this off of a stir. I mean, I guess I could get a stir off of that right here and just do let, I can't, I guess, delete it or shout it. I guess line lowercase equals line dot to lowercase. That gives us this. Then I want a reference to it. Can I just simply say, okay, a reference to line underscore lowercase dot contains? It's not implemented for standard string. Required because the requirements of the implement standard string pattern for standard string mismatch types. Expected Boolean found a reference to Boolean. Oh, really? Oh, I referenced the result of running these, not specifically line lowercase. So if I'm running this query.to lowercase dot to stir, can I do that? Is there a to stir? Doesn't look like it. Let's see how they're doing it. So query equals query to lowercase. So that's the first thing they're doing is shadowing query and making that. And I believe we're doing that right here too. So query to lowercase. Let mute results equals vec new. We're doing that right here. For line in contents.lines. So we have that exactly. If line to lowercase contains a reference to query, that's the key. Okay, so if line.to lowercase contains, so let's take a look at what this error message is again. it's saying, hey, attempted to take value of method 2 lowercase on type stir. I missed this part first here. I was just saying, oh, I also forgot. Put in parentheses here. Okay. So we get this trait is not implemented. Yeah, that was a very different error. So it's not telling me what the best thing to do for it is. Yeah, the first error wasn't that close to being clear. That is true. So what I need to do is put a reference into query here. And then it works. Okay. Oh my gosh, I did not realize that this is all I need to do is like not a string, a stir. Okay, so this, like, our entire thing is working now. Let's come take a look at this again. First, we lowercase the query string and store it in a shadowed variable with the same name. Calling to lowercase on the query is necessary, so no matter where the user's query is Rust, 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 or Rust, we'll treat the query as if it were Rust and be insensitive to the case. Note that query is now a string rather than a string slice, because calling to lowercase creates new data rather than referencing existing data. Say the query is Rust as an example. That string slice doesn't contain a lowercase u or t for us to use. So we have to allocate a new string containing Rust when we pass query as an argument to the contains method now. We need to add an ampersand because the signature of contains is defined to take a string slice. Next, so I think what would have helped out here would have been if we had come in and seen contains. Where's contain? Right here. So if we open up this and we take a look at contains, we would see self pattern P. Yeah, because they're sending in just literal strings like this, which are stirs. They're string slices or references to strings. So that I think if we had paid a little bit of attention to that, we would have noticed that as the problem. But we didn't, so let's not worry too much about it. Next, we add a call to lowercase on each line before we check whether it contains query to lowercase all the characters. Now that we've converted line and query to lowercase, we'll find matches no matter what the case of the query is. Let's see if this implementation passes the tests. Which it does. Great, they passed. Now let's call the new search case-insensitive function from the run function. First, we'll add a configuration option to the config struct to switch between case-sensitive and case-insensitive search. Adding this field will cause compiler errors since we aren't initializing this field anywhere yet. So let's call the new search case-insensitive function from the run function. So is it possible to set... Oh, it's the config. So we're just going to change the config so we can have search case-insensitive true or false. So since we've been doing this test-driven, we have our integration test where we test the run function. And this first thing is... what do we got here? So we pretend to get our input. We then create create config for new unwrap. Okay, so I think what we want to do is, because we're just creating config from here, we're also going to want to put in what is the Boolean for this. So if we just say case-insensitivity is case-sensitive true, so we want it to be false to begin with. Then we'll unwrap, we'll get the config, and then we pass this in, and now we expect the text of hello world to be hello world. And that's simply from this test, the single line.txt, hello world. We can also put in hello world like that inside of here. So now we know, okay, we're looking for something. This feels a little bit odd. So this is our query string, something starting from single line.txt. We shouldn't be getting any of those back. Like, the query that we're getting should be nothing at all. That's actually really interesting. I would actually change this to like hello if we're doing false for case sensitivity, which is really just normal. So if we change this, now we have an error, and we can run our test for it. Expected one parameter, so we now have to come in to the library. We have to find the public struct config here. So public file name, pub case sensitive, cool. I don't know why B is lowercase in this case. It would be nice if it was uppercase like all the other ones. Okay, so this becomes false like that. And let's run this. Missing case sensitive. Wait, where is this? Grep config, OK config, missing case sensitive. And this is missing field case sensitive of initializer grep config and OK config, line 14 of live RS. Oh, okay. So yeah, I'd also need to initialize this with case sensitive. So we'll just go ahead and say case sensitive true. Okay, this function takes one parameter, but two parameters were supplied. Grep config new input false, expected one parameter, but it got two. Oh, right, because I need to also say when we're creating a new one, it's input vector string, but also this is going to be the Boolean, which would be case sensitive is a bool. So we do that. Case sensitive is just going to be sensitive. This function takes two parameters, but one parameter was supplied. And librs line 74. Oh, interesting. Source librs line 74. We're also creating a new result. So let config equals, oh, grep the standard parseInt. So yeah, it needs to return a Boolean. Does it need to return Boolean? It needs to return the config, I think. So standard in, and then this needs to be something like true. Let's try it again. This function takes 2 parameters, but 1 parameter was replied, but now we're in the main function. So now inside of main rs, this is saying, hey, config is this in the args, and we can just say false for right now because nobody's looking for that. Oh, VS Code, you're completely wrong again. Okay, so running one test, get entire text, failed because the left was hello world, new line, hello world, and right was hello world. Well, that's also a completely different problem. I wanted you to be, oh, I guess it would be printed out normally, so like it wouldn't really matter. So this should be part of the test here. But okay, so that is sort of working right now. And I think what the deal is, we're gonna have to come down here and put this into what we're doing next. So in our README, what does the panic look like? Extracting logic from main. Now what we're doing is changing until here. We're doing the implementing the search case function. Let's copy you. And where were you? Right here. So if I click on you, that'll give us the URL. Okay, so that will now be available when we send this all up to GitHub. So let's go ahead and do that before I forget. So we have the README, all of everything else is going on. So we have changing, so it's a work in progress, and we're going to be changing or adding ability to search Case-Insensitive and sensitive using env variable, all env. There we go. We'll send this on up to GitHub. I have the link for this down in the stream description, or if you're watching the VOD, in the YouTube video description. So something else we did here is that we ended up having to find this to lowercase here. Let's go ahead and add this into the wiki. So in Learning Rust, wiki. All right, so where do we want to put this? We have printing values, enums, error handling, hash maps, and can also put in stir methods. stir methods. Save this page. So we'll go to this, we'll go here, and now we'll be able to stir methods, and specifically the one we're interested in is two lowercase. So two lowercase. This is a method that takes in a stir and returns a string. As imagined, it makes a it lowercases the stir that was used. It doesn't change in place. And then the place, like what we can put in here is where we can find documentation for two lowercase if I click on this, that gives us the URL. Add that into here. Okay, so I didn't want to save the web page. I'm too used to save. So now if we ever need this again, there'll be a nice way for us to find it, and also where to go and grab that documentation in case like we can't find the documentation, which is usually the problem that I have the most. Working with environment variables is coming up. So that's it for this morning. We've gone through. We're partway through implementing the search case insensitive function. We might, we're gonna have to sort of look through how they're actually going to set that up, but we still need to do the tests to make sure that the config works and setting all those things up. But hopefully we'll be able to get through all of this and finish this project and begin chapter 13 sometime this week. Anyways, with that, thank you for watching. This has been continuing on very fun. I'm also looking forward to doing some cool new things with Rust once we've finished the book. I have some ideas of some projects to do with it. I am archiving these streams over to YouTube, and I have a channel for them. So that way, if you're missing them or you want to go back and look at other ones, they're all over there. I have links. I have sort of cross links everywhere. So on Twitch, I have links to YouTube and my Twitter account, which is what I used to advertise this stream this morning. And on YouTube, I have the same thing. Also, of course, you could ignore all of those and just follow my channels. That way, you won't rely upon me accidentally forgetting to tweet out that I'm going live, which happens way more often than I would like to admit to. So with that, I'm going to go get ready for the rest of my day, and I'll see you all tomorrow morning at 7 a.m. Mountain Time. Thanks again, and have a good day.